Okay, so let's have a look at number 1 here. It says using sine squared theta plus cos squared theta is identical to 1, show something else. Now, that then implies that we need to start with sine squared theta plus cos squared theta is identical to 1. So sine squared theta plus cos squared theta is identical to 1. I'm just going to write is identical to 1 here. Now, we think about cosec squared. How can we get cosec squared? That's 1 over sine squared. And how can we get cot squared? That's either 1 over tan squared or cos squared over sine squared. So ultimately what we're trying to do is divide by sine squared. So that's what we are going to do here. Divide every single term by sine squared theta. And so we get 1 plus cot squared theta is identical to cosec squared theta. And this almost looks like the thing we want. We just need to bring cot squared over to the right hand side. And so we get 1 is identical to cosec squared theta minus cot squared theta. So that's part A done. Let's have a look at part B. So in part B it says hence or otherwise prove that cosec to the power of 4 theta minus cot to the power of 4 theta is identical to cosec squared theta plus cot squared theta. Now, I'm going to start off with the left hand side. Now, what students often find tricky or sometimes miss out on is recognizing that this left hand side is like x to the power of 4 minus y to the power of 4. Now that reminds me of difference of two squares. So maybe you want to make a note of difference of two squares. Okay, and so if we take over from there, what do we get? We're going to get cosec squared theta minus cot squared theta as my first bracket, and my second bracket as cosec squared theta plus cot squared theta. So we've done that, we've factorized it using difference of two squares. The next thing to spot, we see this word hence, we need to use that because in part A we recognize, or well, we showed that cosec squared theta minus cot squared theta is identical to 1, which is the same as this bracket here. So I can replace this with 1, and 1 multiplied by cosec squared theta plus cot squared theta is just what we wanted, is the right hand side now. Okay, so that is part B done. So key thing there was the difference of two squares. And then part C, it's saying solve between pi over 2 and pi. Cosec to the power of 4. Cosec to the power of 4 theta minus cot to the power of 4 theta equals 2 minus cot theta. So we've got an equation here from part B. Now, even if you weren't able to do part B, what you should have recognized is that part B says cosec to the power of 4 theta minus cot to the power of 4 theta is identical to the right-hand side. So my first step is to write the left-hand side of this equation as cosec squared theta plus cot squared theta equals 2 minus cot theta. Okay, and this was from part B. Now, I've got essentially a quadratic, but using first year knowledge about quadratics in terms of sine or cos, we now have quadratics either in terms of cosec or cot. Now, we can't change this term here because it's not a squared term. So that means everything else has to be in terms of cot, the trig terms anyway. So cosec squared, we go up to this identity. This is something that you learned earlier. Cosec squared is 1 plus cot squared theta. So I can replace this cosec squared theta with 1 plus cot squared theta. I've got another cot squared theta. If I bring the cot theta and 2 over to the left-hand side, I get plus cot theta minus 2 equals 0. And now if I should recognize now that this is a quadratic in terms of cot. So I get 2c squared, where c is cot theta, plus c minus 1 equals 0. Now once I have that, what I can do is, just as a move, let's see if I can try and get it to move. Oh, dodgy mouse. Right, okay. So on here, we are going to use the polynomial solver function. We can solve the quadratic using that. So 2 is A, 1 is B, and minus 1 is C. And so we get cot theta either equals a half or cot theta equals minus 1. Now, cot theta is 1 over tan theta. So 1 over tan theta is equal to a half. Or tan theta equals 2 from there. Or 1 over tan theta equals minus 1 over 1. So tan theta is going to equal minus 1. Now I need to find 2 theta values. Well, I need to solve for theta, but I need to understand that my theta range is between minus pi over 2 and pi. Now, if I just work in degrees for the moment, that's the same as saying 90. Theta must be between 90 and 180 degrees. And if I'm solving tan theta equals 2, and I think about my cast diagram, tan theta is positive. A positive angle will either be in the A quadrant or the T quadrant if tan is positive. So therefore, if theta has to lie between 90 and 180, so it has to be in the S quadrant, there are no solutions in the S quadrant. So this particular tan equation, tan theta equals 2, has no solutions. Now let's look at tan theta equals minus 1. Well, where is tan is now negative. So 0, 90, 180, 270, and back to 360. If I think about tan theta being negative, which quadrants is tan theta negative in? Well, sine is one of them and cos is the other. So we know that we have got, there's going to be one solution in that quadrant. And so if I do theta equals inverse tan of -1, you get -45. And so the angle, we ignore the minus, and the angle from the horizontal is 45. So your two solutions are either 180 minus 45, which is 135, or the second one is going to be 360 going back by 45 is 315. But this one's not a solution because it's out of our range. We only want the solution that's between 90 and 180. And we can't forget to convert it into radians, because our original range in the question was in radians. So how do we convert from degrees to radians? We multiply by pi over 180. And so we get 3 pi over 4 radians as the answer to part C. Now, at this point, maybe you did it using a graphical method. Maybe you're not used to using a cast diagram. That's entirely up to you. There's different ways of getting the final step. The key bit of understanding here was to get a quadratic in terms of one of the trig ratios, and then get your solutions, and then basically solve trig equations. Okay, now the final step is entirely up to you how you did it. Cast diagram is just one of the methods that you can use to solve this. The key thing was to get from what the question told us to this.